So, welcome to another lecture. In this lecture, we'll be looking at this beautiful JEE problem. Why I like this problem is because, unless and until you really understand the rolling motion concepts, it would be very difficult to do this kind of problem. So, let's start this problem. A ring of outer radius 3r rolling clockwise without slipping on a horizontal surface with angular speed omega. So, this is the outer ring. I'll draw it here. So there is a outer ring which has a radius of 3r and it is rotating in the clockwise direction with angular speed omega. This is mentioned here. An inner disk of radius 2r rotating anti-clockwise with angular speed omega by 2. So there is a disk inside. So this is there is a ring outside and there is a disk inside. This disk has a radius of 2r and this disk is moving in the opposite direction to the outer ring. So there is a ring. See, what you need to understand is there is a ring outside. So what you need to understand is there is a ring outside and there is a disk inside. The outer ring has a radius of 3r and the inside disk has a radius of 2r. This is moving in the clockwise direction with angular speed omega. The inside disk is rotating in the anti-clockwise direction with the angular speed omega by 2. So understand this well. The ring and disk are separated by a frictionless ball bearing. The system is in XZ plane. So this is the XZ plane. So this would be my I vector. This would be my K vector. And using the right hand rule, going inside the laptop screen would be my J vector. So you should be very clear about this Cartesian coordinate plane because we'll be using vector cross product while doing this. So please understand this x, y, z axis very well. I'll rub this. Okay. The point P on the inner disk. So there is a point P. This is a point P. Is at a distance r from the origin. So this point, random point P, is at a distance r from the origin, where OP makes an angle of 30 degree with the horizontal. So this point P makes an angle of 30 degree with the horizontal. Then with respect to the horizontal surface, the velocity of point P is given by, so we have to find the velocity of this random point P. Now that is why I was calling this a beautiful problem, because you really have to understand the concept of rotational motion well. See, if you understand the concept well, you can start doing the problem. You can pause the video, try to do the question. If you have a fair amount of understanding of rotational motion, but you are not an expert in the fundamental concepts, what I'll suggest is please have a look at these two videos. This is the first video that is there. There is another second video which is there. This velocity at any point of rolling wheel without slipping would help you a lot. So I'll suggest please have a look at these two videos also. Maybe after you have watched this video, you can have a look at these two videos. So coming back to the problem, there is a ring which is in the clockwise direction outside. There is a small disc which is moving in this direction, and then you have to find the velocity of any random point P inside the disc. And they have given you the coordinates of the point P also, which is at a radius r. See, before you start the question, you should try to understand that, see, finally the disk is moving from left to right. So the translation, as we understand in the all these rolling motion problems, is that the velocity is given by the translational motion plus the rotational motion. So this is how we find the velocity of any point. So for example, in this point, I'll say velocity of point P. So it will be a translational motion plus the rotational motion. Now, in this problem, the beautiful thing is the translational motion will be given by the velocity of the ring. This ring, which is outside, would be deciding this Vt, and the disk which is inside, that will be deciding this Vr. So you should be very clear about it. Another thing that you should be very clear about is the vector addition, vector cross multiplication. That is another thing that we'll be using. So you should be clear about that also. There's a similar problem that is what I was. Another thing that I wanted to add was there's a similar problem I had done. Uh, this is another problem which I have done. You can have a look at that also. I'll mention all these lecture video links in the comments below. You can have a look at this also. So this was also a very interesting problem to solve. So this is a figure which I'll be referring to when I'll be solving the problem. This is, for example, in this case also, this is a random point, and this is what I was saying. The velocity of a random point is given by the sum of the translational motion. The translational motion is given by the velocity of the center of mass plus uh, the rotational velocity component, which is shown as VR, which is given by VR. So these are the two components, the translational component and the rotational component. These are the two components which will decide the uh, velocity at any random point P2. So this diagram you should be very clear about. Another thing that you should be very clear about is that this Vt, the translational part of the velocity, would be given by the vector product of omega by the radius of the wheels. So, for example, in our case, see, that is very critical to understand. This translational component is, for example, in the figure which I am showing you right now, this is a single disk which is moving from left to right. Here, the R would be this, would be the total R. But in our case, the translational motion is being decided by this 3R, because the translational motion is being decided by the ring. That you should be very clear about. So that is why when I'll show you the solution, you will see omega is the angular speed of the angular speed of the ring, the outside ring. So this is omega, and R in our case would be 3R. And of course, because it is moving in the clockwise direction, if I have to put it in vector notation, and my coordinate axis, see, my coordinate axis has been defined like this. This is my x, this is my z, and my y axis is in the this direction. So this is deciding my I, this is deciding my j, this is deciding my k. And because I have to use the right hand rule, my translational velocity, the vector notation will be, this would be my magnitude, and this j component would be giving me the vector translational velocity which is in the right hand side. I hope this is clear. I hope this is clear. Or should I explain this again? I'll explain this again. If you have understood, you can skip this part. See, what I'm trying to tell you is that this ring is deciding the translational motion, which is in the right side. So the translational motion would be given by omega 3r j. This is my in terms of vector notation. This is how I'll find the translational part of the velocity. Now I have to find the rotational part of the velocity. This rotational part would be decided uh, by the inner disk. The magnitude is omega by 2 and the position is r. And I'll have to use the formula uh, omega by 2 is, if you see, omega by 2 is in the anti-clockwise direction. If I use the right hand rule, this is coming out. Because this is coming out, this would be minus j vector. I hope this is making sense. So this is the omega part. This is the omega part, and cross product by the radial, position vector. The position vector is decided by, if I try to zoom it, the position vector would be shown something like this. Let me draw it here. The position vector would be shown like this. This is 30°. This is O. This is R. This is our point. This point P is this point P. So if I have to find this position vector OP, this would be cos 30 comma sin 30, r cos 30, r sin 30. So vector OP would be r cos 30 I plus r sin 30 j. This would be my OP, the position vector. And then for finding the rotational velocity, I'll have to take a cross product of the, because velocity, rotational velocity is omega cross r. In our case, for the disk, in our case, for the disk, the magnitude is omega by 2. It is moving in the anti-clockwise direction. The position vector is given by uh, r cos 30 I, r cos 30 I plus r sin 30. I'm sorry, in our case, our notation is like this. This is I, this is K. So this won't be J. For us, this would be K. Hope this is making sense. Because our vector, our Cartesian system is like this. So the position vector won't be J, this will be K. So finally, I'll find this. This I have found. I'll have to find the cross product of this, and then I'll add the two, and then I'll find the velocity vector. So I've done the calculation here. You can have a look at here. So this is, I've drawn the figure again. Just to recap, this is in the omega direction. This is in the clockwise direction. This is in anti-clockwise direction. Omega by 2 omega. This is my Cartesian plane. Uh, Same thing. Now this is what I was trying to say, that the outer angular is omega j and the inner disk angular velocity is minus omega by 2j, because see, the outer ring is in this direction and the inside disk is in this direction. Angular velocity is a vector. You have to remember that. So the translational velocity due to right is omega 3r. This was decided by the ring, as I have been repeating again and again. This is my position vector r cos 30 I. See, this should be k. Don't write this as j. So finally, this is my position vector, and my position vector is the translational component, which is this, and my rotational component, which will be given by omega cross the position vector of the point where I want to find. So this will be the cross product, and then calculation are there. This is 3 omega I, j into I. Then you have to apply the cross products. So finally, this will be the final answer. So my final answer would be 11 by 4 omega r I plus root 3 by 4 omega r k. This is my final answer. It is in ik. It is in the plane which is given. So this is my answer. If you want to level up this problem, that is what I was saying. I had solved this problem, another JEE problem, but what I did was, in this case, how I did the problem was, you should have a if you want to level up your practice skills. What I did was I made this as 60 degrees. I made this as 30 degrees, and then I calculated the velocity of VQ, VC, VP. Uh, Again, that's a great lecture. You should have a look at that also. So I hope this was useful. Like all JEE problems, this every time you solve a JEE problem, it teaches you a lot. So best of luck, and hope you learned something new in this lecture. So thanks a lot for watching, and best of luck.